This video is going to cover two kind of separate things. So the first thing that we're going to be looking at is how to write a function that represents a situation. So in the projects that you did and in the word problems that we did after that, each time you were told, here's the situation, here's the function that represents it, now solve for the vertex or solve for the x-intercepts. You know, find how long it took to hit the ground. So what we haven't done is what to do when you're not given what the actual equation is. So we're going to look at this. You can probably do this pretty easily. You probably figured out what each of them is, but let's look at it. So if a rocket is launched from a platform 20 feet above the ground and launches at an initial velocity of 120 feet per second, write a function that represents the rocket's height as a function of time. So the first things you've got to figure out is what goes in front of the t squared, what goes in front of the t, and what goes at the end. Now, in every single one pretty much that we've done that had a rocket, we always started out the front as, let's change the color, as -16. Okay, so this is basically representing gravity. Okay, force of gravity. This is what makes it go up, then come back down. The second term, the t term, what we call the linear term, in this case, is always the velocity. So whatever your velocity is, you put it in front of the t. So here it is positive 120. And then at the end, that is your starting point, your starting height. So in this case, your starting height is 20 feet. And it's above the ground, so it's positive 20 feet. So that is how you write a function to represent a situation. You have to take into account the force of gravity, then the velocity, then the starting height. This is a great question that might be given to you on the non-calculator portion of the test. Now let's talk about comparing these functions that we've been looking at. So at the top you'll see that we have which of the following has the greatest maximum point. Now, you have three options here. You're given the graph of a quadratic function, you're given an algebraic function, and then you're given a table. Now you have to take each of these in turn and figure out which one has the greatest maximum point. And remember, when we talk about anything that's maximum or minimum, which point of the graph are we talking about? You should know that by now that we're always going to be talking about the vertex. So what we have to do here is compare the vertex in each of these pieces of information. So let's look at the graph of the quadratic function. It should be very easy for you to find the vertex of this one. Until the vertex is over 1, 2, 3, 3.5. So 3.5, and then it's up 1, 2, 3, 4, maybe 3.5, but we'll say 4. Okay, so here, when we're talking about the greatest maximum point, we're talking about the highest, so that's the y value of the vertex. So our y value of the vertex is 4. Now let's look at our algebraic function. You should recognize from in class that this is written in vertex form, which means you can easily figure out what the vertex is. The vertex, the x value, is the opposite of what's in the parentheses, so it's 4, and the actual of what's in the parentheses, which is 5. Okay, so that is obviously bigger than the graph of the quadratic function. So automatically right now we know this does not have the highest point. So now we just have to compare it to the table. When we're comparing it to the table, we're looking for the y value that is the highest, and then the repeating y values that go down on each side. So you'll see here that we have 0, 5, 8, 9, 8, 5. So which one of these points would represent where the graph turns? That would be this point, which has to be the vertex, 0, 9. So if we're looking for which one has the greatest maximum point, we're comparing the algebraic function, which has a highest point of 5, versus the table, which has the highest of 9. Therefore, the table has the highest point. So, go answer the questions and make sure that you submit them on Google Classroom.